Hi there, I'm Heather Beadle from the ASPE Consortium, and I'm going to talk for just a few minutes about some of the attributes we like to use for compressional terrains. So some of the ones that we like for compressional terrains are the geometric attributes like coherence, curvature, and aberrancy. And these are really great for mapping faults and basement faults and identifying fault blocks. We also have you can also calculate volumetric curvature, which is a little bit better at subseismic resolution fault, and you can use the most positive and most negative curvatures. There's coherence and texture, so GLCM is the texture attribute we're a fan of right now, and those are great for discrete discontinuities and showing lateral changes in reflectivity. And then dip and azimuth analysis are always other ones that you should try to run for your compressional terrain kind of goals to help you visualize the fault block rotations, help you find those four-way closures. So let's look at some examples. Here we've got a reverse fault in Alberta, Canada, where you can see coherence that's been run, and it shows those on echelon faults that are running north to south. When we look at it with a different view, we can see the coherent straddle slices going through here with the vertical slices through the seismic amplitude that are drawn orthogonal to the faults. And so you can see how the en echelon faults help you break up the seismic volume to look at it. You can also use the long wavelength most positive curvature as a cube, and it corresponds to the stratigraphic cube that we just saw in the last slide. Here you can see the fault fracture kind of flexure lineaments extending and kind of augmenting the pattern that we had observed in coherence. And of course, you can also look at the most negative curvature as we're showing here, which complements the most positive curvature that we just saw, kind of helping with identifying the direction of faults and fractures. Okay, so now we're looking at a time slice in offshore Trinidad near the El Diablo 1 discovery. And so you can see the seismic volume on the left and then the coherence volume on the right. And so these discoveries were found in blocks that were bounded by strike, slip, and anethetic faults, such as those that we're trying to point out with the arrows. So the complex faulting is really difficult to detect in the seismic time slice on the left, but you can see it quite clearly in the coherence on the right. And now here we're looking at time slices through the coherence, but also the dip magnitude and azimuth. So the color wheel shows the direction, the azimuth of the dip. And then there's a corresponding kind of gray transparency overlaying to help with the dip magnitude. And so now you can see that the faulting is pretty simple, and the dip is gentle in the north side and kind of to the northeast where it's more magenta and blue. But to the east of the zone, where we're kind of pointing at it with some arrows, you can see that it gets quite complicated. Deformation becomes more intense. So these were just a couple of really quick examples through compressional terrains. There's more up on our website, and we are always happy to answer questions. Thanks for listening.